Okay, we're talking about triangles today. So, unfortunately, we had a problem in our homework that dealt with the triangle. I'm sorry, but it was fairly easy to make up and to figure it out with a couple hints. So we're going to start off. We say that when two items are congruent, basically means they are the same.
Can't see that.
So it's the same. 2. All the angles in a triangle add up to 180 degrees. So that's standard things that we have to realize. The congruency thing, that's normal. You're going to deal with that with a lot of different polygons. But you need to know that they add up to 180 degrees. It's really nice. It's convenient that way. And now there are 3 types of triangles. If you have the handouts, you have all 3. If you watch the slides, I have to draw one on the bottom because somehow I lost one when making the slides. The first one, what kind of triangle does that look like? It seems like all the sides are the same. So it's a what? What kind of triangle is that? You guys know this. Starts with an E. Equilateral. It's an equilateral triangle. Equilateral triangle, it says all the sides are the same. So all sides and angles are the same. So that's an important thing to know there. What kind of triangle is that second one? That one, some people don't know. What looks like it's happening here? Are they all the same?
No.
No. We can't assume that anyways, technically from the first triangle. But this one definitely looks like they're different, and do they look like they're all different? No, right. I could say that's an obtuse triangle because it has an obtuse angle. The top one we can say is an acute angle because all of the angles are acute, right? So that's another name for those, another classification. But this next one is actually called scaling. Scaling means that no sides are the same. So no sides or angles the same. Now I forgot to on that other, the equilateral triangle, we forgot to, because it says put your marks on there. Put your tick marks on there. What does it mean when all the sides are the same? What would that look like? If I came across this walking down the street, I'm looking at the sidewalk, on the sidewalk there, and some kid drew this triangle. What would it look like when I'd be like, oh, that's an equilateral triangle? How would I know that? What are those things? Tick marks. So I would put a tick mark on all of the sides. If I saw a triangle with those 3 things on there, I know equilateral triangle. What else would be a dead giveaway? There'd be tick marks somewhere else. Tick marks on all of the angles. So it'll be a tick mark there, tick mark there, tick mark there. All of the angles are the same. That's the nice thing. So when you're given directions saying this equilateral triangle, there are things now we can assume or things that have to be true. Pieces to a puzzle. Now, the one thing I did leave off, and I'll have to draw it in the bottom here, is this one. This one appears to be the name isosceles. And isosceles, what's so special about isosceles? two sides and two angles are the same. And so on the diagram, when we talked about this one in our homework there, you would have tick marks on the two larger sides. If you said there was isosceles, you can assume that. And you would have tick marks on your angles opposite them, right? The angles that open to those congruent sides are also congruent, the same.
Number 17.
No. Number 1 there, it's small, I'll explain it here. Number 1 is a triangle, ABC. Two of those sides, the sides are both 10. And the angle between them is 72. So again, if you had the printout, you could actually see it. On here, it's a little small. I'll fix that hopefully for future use down the road as we start making more of these. It says calculate the missing measures, angle measures. Well, that's B and C, the two other angles that were not given. How do we find that? What do we know about this triangle? If the two sides are the same, it's a what kind of triangle? It's an isosceles. And okay, so that means this side and that side are the same. What else do we know about it? The two angles are the same. What two angles are the same? Okay, I see some lines being drawn. Are those lines the ones opposite? Where are they coming from? The angle that opens to that side, that's the same as the other one, is the same. So therefore, B and C are congruent. And if they're congruent, and do I know what they are right now? No, I don't know what they are, so I got to assign them some variable. Would I name one of them X and the other one Y? If they're the same? No, I would both name them X or both name them Y. And so I'm going to say, hey, they're both X. Now the reason I'm not putting it inside is because I drew those lines there. If you guys have room, go ahead, make sure it's inside the angle spot. Which basically means that those two angles plus 72 will add up to 180. So X plus X plus 72 is equal to 180. Is it okay if I subtract 72 from both sides? And in the same line, add X plus X? So it'd be 2X equals what? 108. Because I'm subtracting. And then, of course, the last step would be divide by 2. The math hopefully isn't too bad. It's, again, visualizing, remembering, understanding of what an isosceles is, triangle, the definitions, and so forth. Oops, I don't mean to cancel off that. But X equals
54.
So 54 degrees. They're both 54. So that's nice. You don't have to write it twice. Any questions? The next one says calculate the missing angles. The nice thing about this is they drop that dotted line from the top to the bottom. It forms a right angle and it cuts it in half. When you drop a line straight down, it forms a 90-degree angle. That is called the altitude. But we also know that that's the height of that triangle. So technically, if I asked you for the area of that triangle, you should be able to figure it out. You have a height and you have a base. What other information do we have? We have some information there. Or what can we say about this triangle? Does anybody recognize? I don't know if you guys know that. I don't know if we did this in Algebra 2 or not. That's a 30, 60, 90 triangle on each side. If you guys did a little bit of trig last year at all. We're going to get a lot to that this year. Each half of that's a 30, 60, 90 triangle. But look at the larger triangle. What can we assume? Well, okay, what can we assume about this? They're the same, okay. But they add up to 2. So that means of the larger triangle, all 3 sides are the same. Therefore, it is a equilateral triangle. And it's same, calculate the missing angles. Well, the missing angles, I would assume, is this one, and this one. And they are all the same. So they should all add up to 180. How many are there? So 3 times some unknown that we don't know. Divide both sides by 3. And x is equal to 60. Now wait a minute. Let's do a little more thinking. Let's do a little bit more thinking on this one. I forgot about this one with my other class. That's 90, right? I'm just taking that one of those triangles. Can you guys see, guys, that both of those triangles would be the exact same? Just flipped. That 90 degrees would be on both sides because it intersects the line perpendicular. We just said or found that this was 60, correct? This box means it's 90. What's left over to solve for y there? What is y? I can actually find that angle too. It's 30.
30, 60, 90 triangle.
30, 60, 90 triangle. We kind of hinted at that already. But 180 minus 90 is 90. Minus the 60 that we know is 30. So it has to be 30 up here. 30, 60, 90 triangle. Remember what that looks like because we will be using that quite a bit. Open your books to page 24, problem number 17. I'm going to use this blue because I'm wearing this blue in my shirt today.
Do you wear polos outside of school?
All the time.
He does. Yeah, you'll see him driving around in his car with a polo on.
So we know, according to the picture in the book, that's a 35-degree angle. We're told that this is 4y. And this is y. And I do believe there's an x on the outside, correct?
Correct.
Someone back me up on that.
I'm learning. I'm trying.
So our goal is to find x and y. Hopefully you guys can see that color on there. I'll change now. And what do we know about this? There's some things that we should be able to say, hey, I know this about certain parts of figures that can be true. What are those? One of them we learned today, technically, and one of them we've learned in the past. This year. Hasn't been long, but we have. What's that? A scalene triangle? Very well could be, right? We don't know that necessarily. Well, I guess you say, unless y happens to be 35. Okay? So we can't necessarily assume that. But it kind of appears that it should be. What can we assume on pictures? What can we assume about this? It's a straight line. All straight lines are 180. So therefore, what do you know about x and 35? X plus 35 is equal to 180. Right?
Yep.
So if I subtract 35 from both sides, x is equal to 145. So that means we know that x is 145. Awesome. Okay, so if I try to get some of this off here because it's a little confusing to have it all on there. So So we know x is 145. What else do we know? The other half of that problem forms a what? Square, rectangle, trapezoid? What does it form? Triangle. Wait a minute. All the angles in a triangle add up to 180. So that means 180 is equal to 35 plus y plus 4y. Would you agree? Now, just like we did before up above, can I subtract 35 from both sides? As we should. And can I combine the y's together? I have one of them, I have four of them, I now have 5 of them. What is 180 minus 35? 145. Interesting, and that will equal 5y. Wait a minute, is there a connection there?
No.
The fact that a straight line adds up to 180, a triangle adds up to 180. 35 happens to be an angle inside. So what we're saying is that x, which was on the outside, that obtuse angle on the outside, equaled the other two angles added together? Interesting. It's good to know. And what happens when I divide both sides by 5? Y is? Someone's got to have a calculator if they can't figure it out in their head. 29. Does that answer our question? X is 145, Y is 29. Yes. Now, what you have to be careful about, though, you have to be careful of what happens if it didn't say find X and Y. What if it said find all of the angles? 145 would be an answer, right? 29 would also be an answer. Why? Why would 29 be an answer still if I said find all the angles? Why? It's okay to answer. Because what's at that angle? Y. Y by itself is 29. But we also should have that angle, which is 4 times 29. Be careful. In the very beginning, it might ask questions like this of solving for X and Y. Other directions, as we start moving through the book, they get away from the direct answer that you're solving your equation for. They want you to solve for something else or explain something else. But you have to know the answer to get there. It all goes back to those ideas that when we've worked with word problems or other problems before, where the last step was always answer the question. So make sure you understand the question as well. Okay? Okay, homework is on page 12. We have it on the side there. Page 12, number 15, 17, 18, and 24. Have a great day.